Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 1524, number of subarrays with odd sum. This question has been asked in Google and DirectEye and it is based out of prefix sum approach. Let's have a look on the problem statement. We are given an integer array ARR and we have to return the number of subarrays with odd sum. They are also saying that the answer can be very large, so return the modulo. Just take the modulo. Okay. What is given to us in this problem statement? Given is an array of integers and what we have to return is number of subarrays with odd sum. Means take a subarray and take the sum of all the elements in that subarray, and that is my subarray sum. Subarray sum should be odd, and if it is odd, that subarray will contribute 1 to our answer. Now, first of all, what is a subarray? Subarray is like a piece of this array, contiguous piece. If I just take one piece having element 3 and 5, this is one subarray, and this is another subarray. This 3 itself is a subarray, and if I take the whole array, this will also be called a subarray. What about the empty array? This is also a subarray. Okay, so now tell me how many subarrays we can have out of this given array that is having odd sum. If I mention all the subarrays will go something like this, starting with 1. 1 is one subarray, 1 3 is one subarray, 1 3 5. Okay, these are all the subarrays starting with 1, these 3. Starting with 3 is 3 and 3 5, this one. Starting with 5 is only one option is there, that is my subarray. And this is empty subarray, like you can say, let's say the sum is 0 in this case. Okay, here sum is 1, sum is 4, sum is 9, and sum is 3, sum is 8, sum is 5. How many subarrays are there with sum odd sum? 1, 2, 3, 4. So the answer would be 4 in this case. Okay, so this is the problem statement, and let's say this is the array given to us, and just find out number of subarrays with odd sum. This is looking pretty simple. And now if I just have a look on the brute force of this approach, brute force will be something like explore all the subarrays, checking all the subarrays, and subarrays are contiguous in nature, so definitely it is going to start from one index and will move in the right direction. So if you just try to get the idea, first of all I started with index 1, first index, or index 0, then index 1, and then index 2, index 0, index 1, index 2. Starting from every index I am going to the right direction. So for every I is equal to 0 till n minus 1, this is going to be my start of that subarray. Okay, and what about the ending? Ending is j is equal to I. We can end at the current index, or j will be less than n minus 1. Starting from I till the end, we have all the possibilities. So let's say in this case, the array is something like this. I can start from this index and end at this index, or end at this index, and at the last index. So the starting part is fixed, ending part is something we are moving, doing an iteration. Okay, this is for the beginner, explaining in a very simple manner that we are running 2 loops and checking all the possible sub. Now you might say that we have I value and we have j value. Do I have to check the sum again while iterating from I to j? No, when we are doing this iteration now, we will keep on capturing the sum while doing the jth iteration. So we can optimize this approach, and you can call it optimized brute force, where we are just exploring all the subarrays, and this is the ith is the starting position and j will be my ending position. And when we are moving j is moving from ith to n minus 1. So while doing the jth iteration, we can capture the sum as well. And whenever the sum is odd, sum divided by 2 is equal to 1, my answer answer will be incremented. So in this case, how many subarrays are there starting from one index? n minus 1. Not n minus 1, it will be n. Why? Let's say n is equal to 3 in this case. 1 to 1 is one subarray, and 1 comma 2 is one subarray, 1 comma 2 comma 3 is one subarray. So starting from index 0, we have n subarrays. Starting from this, we have n minus 1. Starting from the last element, we have 1. So how many subarrays are there? 1 plus 2 plus 3 till n minus 1. And we are checking all the subarrays. So in the worst case, the time will go in the order of n square, or you can say we are going quadratic time. And to capture the sum, we can take one variable. That one variable is not contributing to any auxiliary space. If that sum is odd, remainder is 1, remainder with 2 is 1, then that is contributing to my answer, right? So this was my simple approach where we are able to achieve the solution in order of n square time. Now let's try to solve this problem in some better way. Okay, so let's say this is my array given to me, and this is my current subarray from index I to j, or let's say this is the last position, index j. Okay, and for this subarray, this array will be contributed to my answer if this array has a sum of odd value. Okay, if at this moment I want to know all the subarrays ending at j which are having odd number of sum, how can I get to know that? It means, let's say when I is equal to 1, how many subarrays are there till I equal to 1 which are giving me odd number of sum. If it is odd number of sum, and till this moment, what is this value? This value is prefix sum, and prefix sum can be of even type and odd type, right? So at j, till j, we can have either even value or odd value. And what we want to know is till start ending at j, how many subarrays are there which are going to give me odd number of sum. If till j, starting from 0, I am getting even sum, it means if I remove some portion with odd sum from the left side, right? Let's say if this whole array is going to give me even sum, okay, and then if I just cut a piece of odd sum, the remaining sum will also be odd. Got it? Because odd plus odd is even. This is the intuition behind this approach. Let's say till jth index we are getting even sum. It means we need to know how many portion we can cut from the left side which are having even sum. If we are having even sum till from 0 to j, then what I need to know is how many portion I can cut. Let's say till this portion it is odd, just cut it. The remaining will definitely be odd. If the whole portion is odd, just cut it. The remaining portion will be odd, right? So when from 0 to j, if it is even, then we need to know how many odd prefix we have encountered so far. And for every odd prefix, if we remove that odd prefix, we are having odd suffix as well, ending at j, right? So this is one possibility if we are having even. The second possibility can be when we are having odd value. Let's say starting from 0 until j index, we are having odd sum, okay, but ultimately we require all the number of odd subarrays, right? So if it is odd, let's say if I cut a portion of even portion, then the remaining will also be odd. If this portion is even, then remaining portion will also be odd. So from an odd portion, if the sum of this subarray is odd, starting from 0 to j. If I cut a portion of even size, the remaining will definitely be odd. If I cut all the portion of even size, I will get all the portion of odd sum subarray. Got it? So what I am trying to tell you is that 1, 2, 3. Right? 1, 2, 3. If I start from index 0 till index 0, what is the sum? Sum is 1, which is odd. It means from odd, from the left side, if you can remove the even portion, all the even portion on the left side will give us one odd subarray, right? This is something you need to understand well, that on the left side there is only one portion, which is empty array. Empty array is having sum of 0. So even number of portion, even prefixes are 1 in number and odd prefixes are 0 in number in the starting for index equal to 0, right? For index equal to 0, we have one even portion on the left side. If I remove that even portion, so till 1, this is my whole array. There is one portion on the left side which is empty array, empty subarray. If I remove empty subarray from this, ultimately the remaining sum will be 1, and that will be contributing to my answer. So my answer will be 1, which is empty array. Okay. So at ith index, what I have to know is even prefixes count, which was initially 1, and odd prefixes count, which is 0. So far we have this subarray with value 1 is in my answer. So my answer is 1. Let's move to the next index. Next index is 2. Next index is 2. And so see, after the capturing of one value, you just update the even number of prefixes or odd number of prefixes. Currently the sum is 1, so it means odd prefixes will be incremented. Even prefix was 1 in number, odd prefix was 0. So now after one step in the iteration, even will remain same, odd will be incremented. It means even is, this is even and this is odd so far with value 1. This is the state. This is the even number of prefix, odd number of prefix in the starting. Okay. Now this is, we are at 2. If we are at 2, current sum is 1 plus 2, which is 3. 3 is also odd. If 3 is odd, remove all the even number of portion from the left side. Even number of portion on the left side are 1 in number. It means all the 1 portion will give us odd number of portion. So answer will be plus even number of count. 1 plus 1, which is 2. Okay. Let me also show you what are those answers. First one is 1. Second one is 1, 2. 1 and 1, 2. These are the two subarrays so far that are giving us odd sum. Okay, now the 2 is done. But at 2, the value was 3. 3 is an odd value. So odd prefix will be incremented. Odd prefix will become 2. Even prefix will become 1. Remain same. When I come to 3, third element is 3. My current sum is 1 plus 2 plus 3, which is 6. Now my current sum is even. It means I have to cut odd number of portion from the left. Odd number of portion from left is 2. So those 2 will be added to my answer. Because if I cut odd portion, I will get odd portion again. This even is showing me that starting from index 0 to 3, total is even. If I just cut on odd number of portion, this is odd portion, this is odd portion, then I will get odd portion on the right side. Odd portion ending at 3. Got it? So the answer would be 2 plus 2, which is 4. If I just try to validate it in the starting, what was the answer that I got? That is 135, and now we have 1 2 3. 1 is one subarray, 1 2 is one subarray, and ending at 3 is, this 3 itself is one array, and this 2 and 3 is one array, subarray. I think these 4 are the options only for us, which are giving me odd sum. This is something you have to figure out, and we only require the number, so only the number is sufficient. Okay. Now let me show you the pseudo code for this approach. Initially we are given an array. Let's say this time array is a new array. First of all, I need to know the even prefix count. Even prefix count I will be initialized with 1 because empty subarray is going to give me even sum. What about odd? Odd subarray, odd prefix subarray are 0 in number. What I will do is I will write a loop starting from 0 to n minus 1. Okay, I will update the current sum. Current sum is going to have value of I. So this is my first step, updated the sum, and now I need to capture the answer. If the sum is even, like if sum modulus 2 is equal to 0, if sum is even, what portion? If the sum is even, I want to cut at odd subarrays, odd prefixes. There is no odd prefixes, but ultimately, like, we might have one odd prefixes, so answer will be incremented by odd. Whatever is the odd portion, if we remove the odd portion, only then we will get the odd portion if sum is even. Else part, if it is odd, we have to cut even portion, then we will get odd portion. So my answer will be incremented by even count. So this is my second step, capturing the answer. If sum is even, cut the odd portions from the starting. So we are having odd portion ending at ith element. If we have odd sum, then cut the even portion so that I will be left with odd portion ending at I. Got it? After that, update your even and odd count. And how do we update? If sum modulus equal to 0, even plus plus, else odd plus plus. That's all we have to do. This is my third step. First step is updating my sum. Second one is capturing answer and updating the values of the even subarray with even sum, prefix subarray with even sum, prefix subarray with odd sum. That's our optimized approach, which is going to give us the answer in order of n time. So we are taking order of n time. And what about the space? We are not taking any extra space. We are taking two variables. One variable is even, one variable is odd. You can maintain a prefix sum array as well. Like this is 2, this is 4, 5, 6, and 6, and 6, 12. You can maintain this as well. But that is going to give us order of n time and order of n space. So instead of storing the prefix sum array, I have maintained two variables because ultimately I need the count of the prefix portion which are having even sum or odd sum. Let's code this approach. We want to return the number of subarrays with odd sum. Let's take a couple of variables. Int, let's take inside the function it answer. Initially the answer is 0, and they are also saying that answer can be very large. Return the modulo with 10 to the power 9 plus 7. Let's say the m is equal to 1 2 3 4 5 6 7 8 and 9. And then I'm going to take two variables, even sum prefix subarray. Even is 1 in number and odd is 0 in number. It means there is one subarray in the starting with even sum, zero subarray in the starting with odd sum. Okay, and we will be iterating over every single element in this array I less than array dot length I plus plus. I will take a current sum is equal to array of I, and this sum in the starting is 0. Now there are two options. If the current sum is even, sum modulus 2 is equal to 0. If current sum is even, but I ultimately require the odd sum subarray. If it is even, then I have to remove odd portion from the starting. I will be left with odd portion. So answer plus equal to odd, else answer plus equal to even. For the first index, let's say for 1, what are the odd sum? Answer plus equal to 1. The current sum is odd. If the current sum is odd, I need to add the even portion. Even portion is 1. So till 1, ending at 1, we are having one subarray, which is this one with odd sum. Got it? Now after this step, we also need to update our even and odd variables. If sum modulus 2 is equal to 0, then even count is incremented, otherwise odd count is incremented. See, I also need to update my answer to take a modulo. So answer is equal to answer modulo with m. In the end, I have to return my answer. Right? That's all we have to do. If I try to run over sample test cases, it's working fine. Now I submit the problem. It got submitted successfully. I hope you understood this approach. This approach is the optimized approach with order of n time and constant space. Thank you guys. Bye bye.